Hi guys, we're going to start now with the endocrine system. The organs of the endocrine system are endocrine glands. Gland meaning that it's secreting something. And these secrete hormones into the blood and then by way of the blood go to target organs. These are going to be ductless glands and these hormones are secreted directly into the blood. So some examples of endocrine glands would be a gland that's in your neck region. The thyroid gland would be about right here, and that's important for basal metabolic rate. Also, the pancreas, and the pancreas really is both an exocrine gland, like we saw in the skin, where substances are released into a duct and onto a surface. An example of that would be digestive enzymes that are produced by the pancreas, but the pancreas also makes insulin. And insulin is going to be a substance that causes glucose, which is a carbohydrate, to move into the cells and therefore be stored there. So as we look through, you'll see that hormones can be of different types. Some of them are more complex than others. Some of them are peptides, which are strings of amino acids, or even proteins, and those would be very large hormones. Some of them are derived just from a single amino acid, and they would be much smaller. Those would be your amines. And then some of them are formed from lipids that are derived from cholesterol. I do want you to see down here, though, that if it says corticoid, you can see oid at the end, that's one sign that it is going to be a steroid type of hormone. One of the things the endocrine system does for us is it helps to maintain homeostasis, which means it's going to maintain a constant internal environment even if the external environment is changing. And this all starts with the hypothalamus. So the hypothalamus is what we call kind of our master gland. It's going to be the one that controls the pituitary, which we consider to be a master gland. And it does this by way of what we call neurohormones that are produced and then go through to the pituitary gland. It also is going to produce some substances that are hormones themselves. And there are two hormones, antidiuretic hormone and also oxytocin, produced in the hypothalamus and then sent to the posterior pituitary to be stored. So when we say the posterior pituitary releases hormones, it doesn't really make them. They're made by the hypothalamus. So the major glands of the endocrine system are the pituitary gland, which has both an anterior and a posterior, the pineal gland, which is also in your brain, the thyroid, like I said, it's here in your neck region, and on the back of that thyroid gland are some bits of tissue called parathyroid glands. Parathyroid is important for calcium homeostasis in your body, very, very important. The adrenal gland, what that means is adrenal, renal means kidney, so it's right on top of the kidney. And then the pancreas, I mentioned that is for digestion, but also it produces insulin. And then the gonads, which are the ovaries and the testes. This is a model you'll see in lab, a picture of a model, and you'll notice where it's showing here would be the pituitary gland in the brain, so you can see the darker anterior pituitary and the lighter posterior pituitary, lots of hormones produced by the anterior pituitary. Here in the neck region, this would be the thyroid gland, so that's what it is over here. And then here are these four bits of tissue, 1, 2, 3, 4 on the back, and that's parathyroids for calcium homeostasis. Here are the kidneys. So sitting on top of the kidneys are the adrenal glands, and here is an adrenal, so they've enlarged it. The outer part is called the adrenal cortex, and the inner part is the adrenal medulla. The medulla is the part that produces two hormones called epinephrine and norepinephrine, or in England they call it adrenaline and noradrenaline, so it's the same thing. And then here is the pancreas, and they're showing you over here a structure called an islet of Langerhans, which is what it would look like underneath the microscope. This is where insulin is produced, and another hormone called glucagon that works opposite of insulin, and insulin moves glucose into the cells. Glucagon is going to cause glucose to move out of the cells. And these two, therefore, are called antagonists of each other. That means they oppose the function of each other. They work opposite. And then here is the testis, and the testis makes the hormone called testosterone. And then the ovaries produce hormones, a group of hormones called estrogens, and also progesterone. So when we look at nervous control for hormone secretion, we're going to see sometimes the nervous system will cause a hormone to be produced, and that is common. The nervous system might send a signal, for instance, to the adrenal medulla to cause epinephrine and norepinephrine to be released. But that is not as common as what we see with negative feedback. So negative feedback is a type of feedback that is going to cause an increase or a decrease in the level of a specific hormone. And just like negative feedback we've seen already, if the hormone is produced and it is increasing in amount in the blood, then we might have a substance that's also increasing in amount. And that's going to cause this negative feedback to be produced, and therefore remember, you learned about negative feedback as we were going over a thermostat in your home. And if you turn the thermostat up, maybe it's cold outside and you turn it up, it starts to produce heat. And then after it gets to a certain temperature, let's say 72 degrees, then it shuts off and it waits. And then if it goes down to 71, then the heat comes back on. So really what's happening is we're trying to maintain temperature around a set point. So if the temperature starts to increase, then our body decreases that temperature. And if our body temperature starts to decrease, then we are going to try to increase our temperature. And that's what negative feedback is. And that's the same way these hormones work. So if a hormone, for instance, let's say glucagon causes blood glucose to increase, then what would be stimulated by that increase in blood sugar? And that is insulin, because what insulin's going to do is move that sugar, that glucose, into cells and store it. So we see that if blood sugar levels are rising, insulin can cause a decrease in blood sugar levels and bring them back to normal. So that's why we see that mostly hormonal control is going to be by way of hormones working by negative feedback. The pituitary gland is very small, and it sits in a depression in the sphenoid bone we call the sella turcica. This picture is showing the hypothalamus up here, and also we can see down here the pituitary gland, the anterior, which is darker, and the posterior, lighter. The hypothalamus does control the pituitary gland, and it does so by releasing hormones into the blood, which then go to the anterior pituitary and cause the anterior pituitary to release its hormones. The hypothalamus also produces hormones in these neurons and then releases those down and causes them to be stored down here in the posterior pituitary. Two hormones produced by the hypothalamus and then stored in the posterior pituitary are antidiuretic hormone. And so if we think of a diuretic as kind of a water pill, if it's antidiuretic, it's going to hold water in the body. It's going to inhibit then the release of water from the body and allow us to maintain homeostasis of water balance. If we look down here at oxytocin, this is one that is important during childbirth, for breastfeeding, but also it's a bonding hormone. So this is going to be the hormone that's produced in a baby's brain and a mom's brain right after birth. And it's also produced by couples. So couples that are together and attracted to each other are producing oxytocin. And that increases that and strengthens that bond between them. All right, so the anterior pituitary, remember it's controlled by the hypothalamus, and it produces growth hormone, which obviously would be important for growth and development. A substance called prolactin that causes breast tissue to develop and stimulates the production of milk after childbirth. Thyroid stimulating hormone that stimulates the thyroid gland, so it's made in the pituitary, goes into the blood, goes to the thyroid gland, and causes the thyroid gland to produce its hormones. It's going to stimulate the thyroid gland. And adrenocorticotropic hormone, or ACTH, gets its name because it goes to the adrenal cortex, and it's going to cause it to produce its hormones. One of the main hormones it causes the production of is aldosterone, which is a glucocorticoid. You'll see that later in the notes. Follicle stimulating hormone that stimulates follicles in the ovary. The follicles are where the eggs or the oocytes are being produced. And it also stimulates the production of sperm in a male. And then luteinizing hormone that's important for ovulation in a female. And in males, it is going to cause the production of testosterone. So here's a good picture showing the how this hypothalamus is going to work. And notice the hypothalamus directly stimulates the adrenal medulla to produce epinephrine and norepinephrine. On this page, what you see is how the hypothalamus is controlling the release of hormones produced by the pituitary gland. And it also secretes those two hormones I mentioned, ADH and oxytocin, and then stores those in the posterior pituitary. So I like this picture because it shows you all the places that are stimulated by these different hormones I just went over, but also it gives you the names of the hormones produced by the glands. So for instance, it shows that the adrenal cortex, once it's stimulated by adrenocorticotropic hormone, goes here to the adrenal cortex from the anterior pituitary, then that's going to cause the adrenal cortex to produce glucocorticoids such as cortisol. The thyroid gland is stimulated by the anterior pituitary. The hormone is called thyroid stimulating hormone, and it causes the thyroid hormones to be released, T3 and T4. We see that there's a huge number of hormones and events taking place because of the anterior pituitary. The posterior pituitary, on the other hand, is going to store two hormones that were made by the hypothalamus, and that is ADH and also oxytocin. As you read through the rest of this, I want you to look at the gland, what the hormones are, and then also what the functions of those are. And in the homework for this section, Chapter 11, you're going to complete a table of that. So I want you to go to these PowerPoints and to the different glands, and that's how you're going to complete that table you're going to turn in as part of that homework assignment. I also want us to look at some disorders of the endocrine system, and so I'm showing you some pictures here. Most of these disorders are caused by the endocrine system hypersecreting, or in other words, producing too much of the hormone, or hyposecreting, where it doesn't make enough of the hormone. Some of the pituitary disorders caused by a hypersecretion of hormone are going to be gigantism, and we call this pituitary gigantism. You see how much taller he is, and it is caused by a tumor he had in his pituitary gland that caused him to produce a lot more growth hormone than normal as he was growing in height. And may seem like a great thing, you know, oh wow, I get to be that tall, but he actually ended up dying when he was 24 from neuropathy caused by a infection in his leg because he had to wear braces on his legs. There are problems with these disorders. This one is a pituitary disorder called acromegaly, and you'll notice her facial features are very large and her hands are very large, and that's caused by the bone growing in width. So once the growth plates close, then the bones only grow in width as you're an adult. Produce too much of this growth hormone as an adult, then you can have growth in width. Here's a hypofunction of the pituitary, which leads to dwarfism. And so dwarfism is where the growth of the long bones is abnormally decreased. We can see here one type of dwarfism that's caused by the pituitary, so we call it pituitary dwarfism. And if you didn't pick up on this, this is a large shoe over here. You can see how much smaller he is, and all of his features are in proportion to each other, but he's just a lot smaller. So again, hyposecretion of growth hormone. Diabetes insipidus is caused by a hyposecretion of ADH, antidiuretic hormone. And what that does is it causes you, instead of keeping excess water in your body, it causes you to get rid of fluids. And then that would lead to an extreme thirst, what we call polydipsia. And so that's one of the signs of it. But it is pretty debilitating if you are having to drink about 18 liters of water a day and also urinating that much. Hyperthyroidism is another disorder, and that's where the thyroid gland is over-secreting. And it might be caused by medication, it could be caused by toxic nodules in the thyroid, but most cases are due to an autoimmune disorder that we call Graves' disease. And this is where too much of a thyroid hormone, thyroxine, is secreted, and the person gets an enlargement of their thyroid gland that we call a goiter. The other thing that can happen with this hypersecretion of thyroxine is they can get kind of a exophthalmos of the eyes where they kind of bulge, and I'm going to show you a picture of that. So this is showing a picture of a person with exophthalmos, and notice the enlarged thyroid gland and the eyes. And then in her neck region you can see the thyroid. I mean, it's kind of outlined here because it's so large. Hypothyroidism, on the other hand, is where you don't produce enough thyroid hormone. And one example of this would be myxedema, where the person's face might become swollen, their weight increases, and they have memory failure. So if a person isn't producing enough thyroid hormone, it might need to be regulated with medication. Cretinism is another one. It's usually now called congenital hypothyroidism. So when a baby is born, if they're not producing enough thyroid hormone, over time it can lead to mental retardation and malformation in the brain. And so it's usually tested for when the baby's born, just to make sure that they're producing enough of that hormone. When we are looking at adrenal disorders, the one we want to look at is the hyperfunctioning of the adrenal cortex. And it's really due to the glucocorticoids. So remember, these are produced because of a hormone produced by the anterior pituitary called adrenocorticotropic hormone, or ACTH. That's where it starts. And when it gets to the adrenal cortex, which is right over the kidney, it can cause hypersecretion of one of the hormones, glucocorticoids. Another thing that can cause Cushing's would be if a person is on kind of an artificial glucocorticoid, which we call prednisone. If you've ever taken that or seen someone who had to take that, they may have the same symptoms. And so prolonged use of prednisone can cause this, where a person has high blood pressure, they're going to get kind of that moon-faced appearance, and even we have some redistribution of fat, so there is what we call a hump or a buffalo hump there on their back, and an enlarged pendulous abdomen is another sign of this. And so that's caused by a hypersecretion or hyperfunctioning of the adrenal cortex. Another one for the adrenal is Addison's disease. John F. Kennedy had Addison's disease. It's a hypofunctioning of the adrenal cortex, and so it's really caused by a hyposecretion of the glucocorticoids as well as mineralocorticoids. What ends up happening is the person gets excessive pigmentation, or kind of a bronzing of the skin. It could look kind of tan at first. Decreased blood glucose levels, so tiredness and low blood pressure, weight loss, and then also fatigue. And like I said, JFK had this disorder and they covered it up pretty well. I want you to read through the rest of this PowerPoint, and even those things I didn't cover in as much detail. Make sure you do that before you fill out your homework, and also use your homework to study before you take your quiz. Let me know if you have any questions.